Hello everyone. So in this video, let us discuss about the new chapter, index numbers. So as always, first 1 minute we always think of the logic behind this chapter, right? So why do we have index number as a chapter in our syllabus? What are some examples of index numbers? Let's start from there. I believe you might know about Nifty and Sensex, right? If you have a little bit of knowledge about the stock market, in the stock market, we have two indices or index numbers called as Nifty and Sensex. Now, let me in brief tell you what is Nifty and Sensex. There are two stock exchanges in India, recognized stock exchanges called as National Stock Exchange NSE and Bombay Stock Exchange BSE, right? So NSE is basically of fifth, like in NSE there will be lot of companies which will list its shares, but the Nifty index is the index which gives you the performance of the top 50 companies, Nifty 50. And whereas the Sensex, that is the Bombay Stock Exchange, of course there will be lots of companies which will list its shares, but Sensex gives you the performance of 30 companies. So this index will represent these 30 companies. This index in the case of Nifty will represent the 50 companies. So you need something which will represent all of these companies, which is what we call as index, or in that case Nifty and Sensex. Okay, it also started from a number called as 100, and currently whatever might be the price at which Nifty is trading, that is the growth from 100 till that point. Okay, this is some basics out of the syllabus about what is index numbers. So the point of index numbers is comparison. So we have index numbers so that we can compare. Now compare what? It can be comparing the price, it can be comparing the quantity, it can be comparing value, and so many other things. Okay, so index number is one of the very important concepts when you think from the practical point of view. Okay, even when later on you study taxation, when it comes to CA intermediate and CA finals, you will see the usage of index numbers, cost inflation index, and other concepts like this. So please don't take this chapter lightly. This is easy to calculate but very relevant when it comes to the practical life of a CA. Okay, wonderful. So that is about index numbers. Now let us get the chapter overview. We'll understand what are the different concepts we are going to touch upon in this chapter. So index numbers, we'll have one theory called as issues involved in index numbers, which we'll be covering at a later stage in this chapter. Types of index number will be our primary focus, where we'll have price index number, quantity index number, and value index numbers. Then we'll discuss about construction of an index number. How do we even construct an index number? Then a concept called as chain index numbers. Continuously, if you arrange them, we call it a chain index number. In usefulness of index number, we'll discuss about deflating index numbers and splicing of index numbers. Two wonderful concepts there. And then eventually the tests of adequacy, where we check which is the better index. Okay, we'll have different types of index numbers which we'll calculate. Which is the better one? We'll check based on these tests. So tests of adequacy, we'll have unit test, time reversal test, factor reversal test, and circular test. Okay, so that is the chapter overview. These are the different things that we are going to touch upon in this chapter. Are you ready? Awesome. So well, let's start this definition. What is the definition of an index number? An index number is a ratio of two or more time periods. Two or more time periods are involved, one of which is the base time period. So it is basically a ratio of two or more time periods. Ratio of two or more time periods, one of which is the base time period. The value at the base time period serves as the standard point of comparison. Okay, let's take a very basic example. Let's say, think of your college canteens and the price of Maggi. Okay, let's say we are in 2026 and imagine recently they increased the price of Maggi per plate to, let's say, 25 rupees. Okay, I know it might be expensive or cheaper in different places. I'm just taking an average number. Let's say this year in 2026 they increased the price of Maggi to 25 rupees, and let's say if you do some comparison, you get to know in 2025, just give me a minute. Let's say in 2025 it used to cost 20 rupees, and let's say in 2021, let's say in 2021 it used to cost 15 rupees. Let's say this is how the numbers were, right? Maggi used to cost 15 rupees in 2021, it now costs 20 rupees, and it later on costed 26. In 2026 it cost 25 rupees, let's say. Now, if I ask you how much has the Maggie's price increased from 2021 to 2025 and then to 2026, how would you tell me? You would say, sir, it was 15 rupees in 2021, it has increased to 20 rupees. That means there was an increase of 5 rupees. So, 5 rupees on 15 rupees, because 15 was the earlier price. So, you would say, sir, there was 1/3 increase or 33.33% increase, correct? 15 plus 33.33% is what? 20 rupees, right? So you would say there was a 33.33% increase in the price, correct? And if I ask you from 2025 to 2026 how much was the increase, you would say, sir, it was 20, it got increased by 5 rupees, so 5 by 20, which is basically 5 by 20 is what? 25%. So you would say, sir, there was an increase of 25% in the value. So to 20, if I multiply by 25%, I get 5. So 20 plus 5, now it has become 25, right? The same concepts we are turning into a specific number called as index number. Okay, nothing else in this chapter. We are just trying to compare the increase in price, compare the decrease in price, compare increase in quantity of production, and all of those things using index numbers. Okay, a quick question to you guys. What is the increase in price of Maggi from 2021 to 2026? If I ask you, how would you calculate? Directly 15 to 25, there was 10 rupee increase, divided by 15 into 100, right? So 10 divided by 15, you would say 67% or 66.66% increase, right? So my question here was, from 2021, what is the increase? From 2021, what is the increase to 2026, right? That means I am keeping this as the base period, correct? I am taking this as the base period. That is what we discussed here. The value at the base time period serves as the standard point of comparison. So I am taking this as the base and then I am calculating. Understood? Now, I told you we are giving a number, right? Instead of percentages. Now we took about percentages. 15 to 20 means 33% increase, 20 to 25 means 25% increase, 15 to 25 means 67% increase, right? Now giving you these percentages doesn't make you feel it's easy to remember, right? Instead, what if I tell you, let's say the price in 2021 is assumed to be 100. Now, next number will be 15 to 20 as a percentage will be what? 33% increase. So, to 100 I'll add that 33. Now, I'll say this has become 133 and this I'll say has become 167. Now, do you see it becomes a little easier for you to do the comparison, no? Instead of this 15, 20, 25, I am saying 15 and treat as 100. This is what we call as base period, and base period index number we always start from 100. Are you understanding? So I am slowly taking you into the concepts. So the base period, whatever values we'll have, we'll always call them as 100, and compared to the base period, I am asking you what was the increase in 2025, so 133. Compared to base period, if I ask you what is the increase here, that will be 15 to 25, 100 to 167. Are you understanding? Are you understanding? This is the crux of index numbers chapter. We'll always denote the base value. It can be price, quantity or value as 100, and then we'll see the comparisons. Is that clear? So that is what we do in index numbers. An index time series is a list of index numbers for 2 or more period of time where each index number employs the same base year. That means if you just check it for 2 years, we call these as individual index numbers. If I list it continuously, then it is called as index time series. Is a list of index numbers for 2 or more periods of time where each index number employs the same base year. Is that clear? Is that clear? Wonderful. So that is this concept of index number. I hope you got the basics right. Next concept is what we call as relatives. One of the simplest example of an index number is a price relative, which is the ratio of the price of a single commodity in a given period to its price in another period called the base period or the reference period. Okay, one of the simplest example of an index number is a price relative, which is the ratio of the price of a single commodity in a given period to its price in another period called as base period. Now in fact, what I just showed you here, Maggie for 2025 compared to 2021 is an example for price relative. So how do you calculate price relative? Pn divided by P0, that is basically current year price divided by base year price. Understood? So current year divided by base year is price relative. It has to be expressed as a percentage. So price relative formula will be Pn divided by P0 into 100, which is what we popularly call as P1 divided by P0 into 100. Pn is basically current year ka price, which is what we always easily denote as P1. Okay, so if it is one single commodity and just comparison from base year to the current year, we call it as price relative. It is in fact an index number, right? One of the simplest example of an index number is a price relative, which is the ratio of the price of a single commodity in a given period to its price in another period called the base period or the reference period. Understood? So if the question is given as the price of Maggie in 2021 is rupees 15 and price of Maggie in 2025 is rupees 20, calculate price relative. How will you do it? Current year price, so 20 divided by base year price is 15 into 100, so 20 divided by 15 into 100 is 133. Correct? So this is what we call as price relative. Tell me, even without touching the formula, didn't we get the same answer 133? That's what I told. If you understand the common sense logic, then you will understand the formulas of them. Is it clear? Wonderful. So that is about price relative. Pn divided by P0 into 100 or P1 divided by P0 into 100. There can be other relatives such as quantities, volume of consumption or exports, etc. The relative in that case will be quantity relative Q1 divided by Q0 into 100. Value relative will be V1 divided by V0 into 100. V is basically price into quantity. Value matlab price into quantity. Price is just for one item. No, when I get multiplied it by quantities, I get the value of that product, right? So V1 is equal to P1 into Q1 divided by P0 into Q0. Did you understand price relative? Wonderful. So we have also taken an example where we have actually calculated the price relative. Fantastic. Now, what are the types of index number? There are two broad types, simple and composite. The simple index number is computed for one variable, let's say price. Okay, only for one variable if we calculate, we call it simple index, whereas the composite is calculated from two or more variables. Most index numbers are composite in nature. So generally, whenever we refer to index numbers, we refer to composite index number. Most commonly used and most popularly used are composite index number. Composite index number are also called as weighted index numbers. Okay, they are also called as weighted index numbers. So there are two methods of calculating index number: simple index numbers, weighted index number. In simple, we have simple aggregative index number, simple average of relative. The word here used is relative, but it is actually average of relative. When it comes to weighted index numbers, also we have weighted aggregative and weighted average of relatives. Is that clear? So those are the types of index numbers. Now let's move to the first one under the types, that is simple aggregative method. Simple aggregative method. Very easy to understand. Now P01 means base year and current year. Okay, P01 means base year compared like current year. 0 is base year, 1 is current year. So if I say 2021 is base year and 2025 is what I want to call, this is 0 and this is 1. So I am finding index number for 2025. I'll call it as P01 with base 0 and current year as 1. Okay, so that is how we commonly denote the price index numbers, P01. And the formula is very simple: current year total divided by base year total into 100. Guys, come on. See here, we did current year divided by base year for one product, right? If you do the total of all the products for current year and base year and then get an index which will represent the entire set of values, we call it as simple aggregative. Understood? We have an example here. Cheese per 100 grams is 12 rupees in 1998. It became 15 in 1999. Egg per piece was 3 rupees in 1998. It became 3.6 in 1999. And potato per kg was 5 in 1998, 6 in 1999. Similarly, we have the data for 2000 as well. So, if you are expected to calculate price index number using simple aggregative method, what you do is you do the aggregation. See, the name itself suggests, right? Simple aggregate. You do the aggregation of prices of 1998, prices of 1999. So what is the aggregate of 1998? 12 plus 3 plus 5 is 12 plus 3 15 plus 5 is 20. And when it comes to 1999, it will be 15 plus 3.6 plus 6, which is 24.6, right? So you have the aggregate of prices for both the year 1998 and 1999. So if someone asks you the price index number for 1999, taking 1998 as the base, you basically do summation of P1, that is prices of P1, which is, see, this is P1, right? This is P0. Why? P0 is base year, P1 is the current year. Current year matlab the year for which the index is calculated. So summation P1 divided by summation P0 into 100, which will be 24.6 divided by 20 into 100. Are you understanding this? 24.6 is basically the aggregative of 1999 divided by base year. The total is 20 into 100. 24.6 divided by 20 into 100, you get 123 as the price index. 123. Correct? Now, the same data, keeping 1998 as the base, if we want to calculate 2000, index number for 2000, it will be 15.6 plus 3.3 plus 5.7. So 15.6 plus 3.3 plus 5.7 will be 24.6 once again, and the index number will be 24.6 divided by 20, because base year we are keeping as the same, right? Into 100, we again get 123. So index number for 1999 is 123 and for 2000 also it is 123. Okay, one of the very basic formula and very basic way of finding index number is simple aggregative. Simply aggregate, just like how the name suggests. What are you supposed to do? Simply aggregate and take current year total divided by base year total into 100. So whichever current year is asked in the question, if they ask index number of 2000, you will take the current year total, which will be 24.6 divided by 20 into 100. If the question is about 1999, take 24.6, the total of 1999, divide by base year 20 into 100. Did you understand? Pretty simple to do, right? Wonderful. So that is about simple aggregative method. Okay, there cannot be any complication in these kind of questions. Straight away prices, straight away current year price, then you will get the values. Is that clear? Awesome. So that is simple aggregative method. Next, we have simple average of relatives method. Simple average of relatives method. The above method is easy to understand, of course, but it has a serious defect. It shows that the first commodity exerts greater influence than the other two because the price of the first commodity is higher than the other two. Right? If you observe, 12, 15, 15.6. The other numbers are 3, 5. So what change has happened in this compared to what change is happening here? If you see here from 12 to 15, you may feel 3 rupees. Oh my god. But here from 3 to 3.6, there is a 20% jump. Are you observing? Like, just because the numbers are small, those are being ignored when the totaling happens. That means what is happening in simple aggregative? We ignore the magnitude of the numbers. We simply take the totals. Isn't that little unfair? Right, let's say here it was 100 and 150. Now can you compare 100 150 with 3 and 3.6? Doesn't make much of sense, right? That is where we have the concept of simple average of relatives. To avoid this kind of inconvenience, basically, like if numbers, like basically you get the point, right? In simple aggregative, what is happening is you are simply aggregating, so you are not giving specific importance to each of this, you are just looking at all of them together. So that is why we have simple average of relatives. One way to rectify this is to construct a simple average of relatives. They are relative to the value for the base period. The index is the average of all such relatives. So you know what is the solution for this issue? See, here we were doing the total and then comparing the totals and getting the index, right? Now in the next method, you know what we are going to do? We are going to calculate index numbers for each of this separately. Like I'll do 15 by 12 into 100, 3.6 by 3 into 100, 6 by 5 into 100. So I'll get 3 index numbers individually. These are called as price relatives, right? If we calculate for one commodity for one period, we call it price relative, correct? So I'll get price relative for this, I'll get price relative for this, I'll get price relative for this. Then I'll take the average of these three, and that will be my simple average of relatives. Did you understand why it is called simple average of relatives? We calculate a relative price index for each of this separately and then take the average of the price relatives. Is it clear? Wonderful. Now, when we say average, remember measures of central tendency, there are different types of mean, AM, GM, HM. Right, so which are we going to use? The commonly used ones are arithmetic mean and geometric mean, but for our syllabus here we will be covering just the arithmetic mean, simple average of relatives. Okay, so we are going to touch up on only one of that is simple average of relative using arithmetic mean. What is the formula? Simple summation capital P divided by N. What is capital P here? Price relative, which is P1 divided by P0 into 100. So I have told you already the steps, right? Like for each of the commodity you will calculate price relative. So that is this P that we are talking about. Total up all the price relatives and find the average. That is the simple average of relative index number. Okay, we have an example over here. Calculate unweighted average of relatives using arithmetic mean for 1997, taking 1995 as the base. Unweighted average of relatives means simple average. Simple and weighted I told, right? So simple is also known as unweighted. So unweighted average of relatives using arithmetic mean for 1997, taking 1995 as the base. So we'll have commodities A, B, C. 1995 is the base. We need to calculate average of relatives for 1997. So I'll have 13, 2 and 7. Here I'll have 15.4, 3.2 and 6.7. So I need to calculate the price relatives. Then whatever I get here is summation P. So my calculation will be summation P divided by N. Correct? So what is the price relative? 15.4 current year divided by base year into 100. Correct? Here it is 3.2 divided by 2 into 100 and here it is 6.7 divided by 7 into 100. Do the calculation and tell me the answer. 15.4 divided by 13 into 100, you get 118.46 Next you have 3.2 divided by 2 into 100, you get 160. Then you have 6.7 divided by 7 into 100, you have 95.71. So now what are these numbers? 118, 160, 95. Comparatives just for commodity A. So commodity A from 1995 to 1997, there is an increase of 18.46%. 100 iddadu 118 ಆಯ್ತು, correct? I always told you base period is 100. That is why we multiply by 100. Guys, this is even cross multiplication. No, think about it. 13 has become 15.4. 100 will become what? 13 has become 15.4. 100 will become what? That is how we are calculating index numbers. Think, no, see, right, what is happening? 15.4 into 100 divided by 13, right? Never thought about it this way, right? So what we are doing is index number is cross multiplication, guys. We are taking the base as 100, we are saying what is the value for this. So cross multiplication. Okay, I'm making it basic and very easy for you guys, right? I hope you are understanding. Cool. Okay, so 118.46 is for commodity A, 160 is for commodity B, 95.71 is for commodity C. But I want the price index number for all the commodities put together. So I'll take the price relatives ka summation. So 118.46 plus 160 plus 95.71, where I get 374.17. So 374.17 divided by number of commodities or number of price relatives is 3. Divided by 3, I get 124.72. Okay, so the price index number is 124.72. Did you understand the difference between simple aggregative and simple average of relatives? In simple aggregative, we aggregate, we take the totals and one index number. In simple average of relatives, we take relative price indexes for indices for all of the commodities separately. We take the total divided by n to basically get the average relative. Is it clear? Is it clear? Wonderful. So those are the two ways of calculating simple price index, simple aggregative and simple relative. Is it clear? Great. Next, let us discuss about weighted index numbers. Remember, in the types we had simple and weighted. This is that weighted index numbers. So under weighted index numbers, again we'll have weighted aggregative and weighted average of relatives. Okay, so now weighted aggregative index methods. Now here we don't just have one, not two, not three. We have 5 different ways of calculating weighted aggregative index method. But these are all easy peasy, guys. With all of those other chapters done right, this chapter feels like a joke. I don't literally mean that. When I say it's a joke, I basically mean that this is just so easy to calculate, guys. Right? Cool. So the first one is Laspeyre's index number. This is the guy who first came up with this concept. So Laspeyre's index numbers. Here, guys, please pay attention. See, we are finding price index number. So the comparison is always price only. So summation P1 divided by summation P0. Where is that coming from? Summation P1, summation P0. It is coming from this only, no? Simple aggregative. Correct? This is weighted aggregative. So it is an aggregative itself. Right? It is an aggregative. So summation P1 divided by summation P0. That is always the same. We are comparing base year, that is the current year with the base year. So summation P1 divided by summation B0. But we need a weight. Correct? These are weighted index numbers. So we are going to assign weights. You tell me what will be the weights that we can give. We can say price of current year, price of base year is there. If we multiply with the quantities, then probably this will consider the weights. So whatever we get will make sense. Correct? So that is the logic behind this. Now when I say weights, there are again two weights available. Base year quantities, current year quantities. Which one to take? Laspeyre told we'll take base year quantities. His logic is that when we are observing movement of price, we need to keep the quantities constant. So assuming quantities of base year will be continued to be used in the current year, what is the variation in the price? So that is the logic of Laspeyre's index number. So price index number will be summation P1 into Q0 divided by summation P0 into Q0 into 100. Understood? Summation P1 into Q0 divided by summation P0 into Q0 into 100 gives you Laspeyre. So just you need to remember base year quantities are the weights. So both to the numerator and denominator we are taking base year quantities as the weights and calculating the price index. Understood? Next we have Paasche's index number. Now this guy told, this gentleman, sorry for using the word guy, this gentleman told we'll use current year quantities as weights. So we'll use current year quantities as weights. Okay, so that is the only change. That means summation P1 divided by summation P0, then you will have Q1 as the weights both for numerator and denominator. Now Paasche's logic is that when we are comparing prices from base year to current year, and if we are in the current year, because we are calculating index for the current year, so it makes sense to apply current year's quantities to both the prices when we compare the prices. So that is Paasche's argument. Now who is right, who is wrong, we are not discussing that here. Okay, these are two different approaches. Laspeyre says we'll take base year quantities. Paasche's index number says we'll take current year quantities. So the summation P1 divided by summation P0 that will remain, but this time it will be summation of P1 into Q1 divided by summation of P0 into Q1. So you will take price of each of the commodity, multiply it with their current year quantities, you will get P1 into Q1 summation of that divided by, on the other end you will have P0 into Q1 summation of that into 100. Okay, so that is how you calculate Paasche's index number. Current year quantities are taken as weights. Understood? So Paasche's price index number is summation P1 Q1 divided by summation P0 Q1 into 100. Is it clear? Is it clear? So this is the second weighted aggregative index. Now comes Dorbish-Bowley. Now what is Dorbish-Bowley? In short, AM of Laspeyre and Paasche. That means Dorbish-Bowley wants to play safe. What this index number says is that Laspeyre's also makes sense, Paasche's also makes sense. So how do we decide? Nothing to decide, take the average of those two. So that is how we get Dorbish-Bowley. Take Laspeyre's price index plus Paasche's price index, divide it by 2, which is what we call as Dorbish-Bowley price index number. Okay, Dorbish-Bowley index number. So when we write this, it will be summation P1 Q0 Laspeyre's base, right? Summation P1 Q0 divided by summation P0 Q0 into 100 plus summation P1 Q1 divided by summation P0 Q1 into 100. Now the average of this. Correct? When you further simplify, you can take the 100 common out. So in the numerator, you will have summation P1 Q0 divided by summation P0 Q0 plus summation P1 Q1 divided by summation P0 Q0 whole into 100 divided by 2. Understood? So if directly in the question Dorbish-Bowley is asked, you can go ahead with this summation P1 Q0 divided by summation P0 Q0 plus summation P1 Q1 divided by summation P0 Q1 into 100 divided by 2. So the logic is simple. Take the arithmetic mean of Laspeyre's and Paasche's. Okay, so that is the third one. Laspeyre's base year, Paasche's current year, Dorbish-Bowley average of Laspeyre's and Paasche's. Next comes Marshall-Edgeworth. Now this is even more simple. You know what to do in Marshall-Edgeworth? Add the numerators, add the denominators of Laspeyre and Paasche. Okay, summation P1 Q1 plus summation summation P1 Q0 plus summation P1 Q1 whole divided by summation P0 Q0 plus summation P0 Q1 into 100. So the numerators get added. If you see, the numerators of Laspeyres and Paasches are being added, divided by denominators of Laspeyres and Paasches are being added into 100. Understood? So if you know Laspeyres and Paasches, you can directly write Dorbish-Bowley. You can also get Marshall-Edgeworth, right? And I have already told you how to remember Laspeyres and Paasches. Isn't it wonderful? So Laspeyres, Paasches, Dorbish-Bowley, Marshall-Edgeworth. Now, what is Fisher's ideal index number? First of all, see, look at the pressure that we people put on Fisher's. We call it an ideal index number. Now, why is it called ideal index number? We'll see towards the end when we check for tests of adequacy. Okay, but spoiler alert for you guys is that Fisher's is called as the ideal index number. Okay, Fisher's is called as the ideal index number. Now, you know what Fisher's is? Dorbish-Bowley is AM of Laspeyres and Paasche, right? Fisher's is GM of Laspeyres and Paasche. Fisher's is GM of Laspeyres and Paasche, which means price index number of Fisher's is square root of Laspeyres price index into Paasche's price index. So price index under Fisher's is square root of Laspeyres into Paasche's. So when you expand that, you get this square root of summation P1 Q0 divided by summation P0 Q0 into 100 into square root of summation P1 Q1, summation P1 Q1 divided by summation P0 Q1 into 100. When you take 100 common out, you are left with summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1. The entire thing multiplied by 100. Did you understand? So these are the 5 different weighted aggregative index numbers. Is it clear? Laspeyres base year quantity, Paasche's current year quantity, Dorbish-Bowley average of Laspeyres and Paasche's, that is AM. Marshall-Edgeworth, add the numerators of Laspeyre and Paasche's, add the denominator of Laspeyres and Paasche's into 100. Fisher's is the geometric mean of Laspeyres and Paasche's. Is that clear? Wonderful. So that is about the formulas. Now let us take one single question. Let us take one single question and calculate all of this. Okay? Superb. So we have commodity, right? We have commodity. We have base year price. See, it is always represented as P0, P small, base year price. Base year quantity is Q0, current year price is P1, current year quantity is Q1. Okay, so this will be what is there in the question. So A, B, C, D, P0, 4, 5, 7, 2, Q0, 3, 4, 2, 3, P1 is 6, 6, 9, 1, and quantities is 2, 4, 2, 5. Okay, now we'll need all different combinations, right? We are taking all the questions at once. So I'll need summation of P1 Q0, summation P0 Q0. I'll need summation P1 Q1. I'll need summation P0 Q1. Okay, I'm writing it this way, but if you guys are comfortable, let's say you had it in your PU and you write P0 Q0, P1 Q1, any combinations, it's fine, but just be mindful if you're referring to my calculation, this is how I write it. P1 Q0 is where I'll start, no, Laspeyres divided by P0 Q0, that's why I wrote it next. Then Paasche's will be P1 Q1, then P0 Q1. So that is how I do it. It is completely up to you which columns you will write first. Okay, superb. So P1 into Q0, P1 into Q0. So we'll be doing this. So 6 into 3 is 18. 6 into 4 is 24. 9 into 2 is 18. And 1 into 3 is 3. So I get summation P1 Q0, summation P0 Q0. So P0 Q0 is this one, right? So 4 into 3, 12, 5 4s are 20, 7 2s are 14, and 2 3s are 6. Right? Next P1 Q1. So 6 into 2, 6 into 4, blah blah blah. So P1 into Q1 is 12, 6 4s are 24, 9 2s are 18, 1 5s are 5. P0 into Q1. is P0 into Q1. Correct? So 4 2s are 8, 5 4s are 20, 7 2s are 14, and 2 5s are 10. So we have all of this. Now let me total it up. So 18 plus 24 plus 18 plus 3, it is 63. 12 plus 20 plus 14 plus 6 is 52. 12 plus 24 plus 18 plus 5, 59. 8 plus 20 plus 14 plus 10 is 52. Let me recheck these figures because these numbers are crucial. If one number goes wrong here, then all the calculations will go wrong. Right? So let me recheck. A, B, C, D 4572, 3423, 6691, 2425. P1 into Q0. So this is P1. Correct? So P1 into Q0. 6 3 is 18, 24, 18, 3. 18, 24, 18, 3. P0 Q0 is P into Q. So 4 is a 12, 20, 14, 6. 12, 20, 14, 6. P1 Q1 is 6 into 2, 12, 24, 18, 5. 12, 24, 18, 5. P0 Q1, right? P0 Q1. So 4 to the 8, 8, 20, 14, 10. 8, 20, 14, 10. Okay, now the totaling up 18 plus 24 plus 18 plus 3, 63. 12 plus 20 plus 14 plus 6, 52. 12 plus 24 plus 18 plus 5, 59. 8 plus 20 plus 14 plus 10 is 52. Wonderful. So we have all of these numbers ready with us. Shall we calculate each of the price index one by one? Are you ready? Wonderful. So Laspeyre's price index number is summation P1 Q0, right? Base year quantities is what Laspeyre told us to use. So P0 Q0 into 100. So summation P1 Q0 is 63 divided by P0 Q0 is 52 into 100. So we get 63 divided by 52 into 100, which is 121.15. Correct? So that is Laspeyre's. Next we have Paasche's. So Paasche's price index number, Paasche told current year quantity. So summation P1 Q1 divided by summation P0 Q1 into 100. So summation P1 Q1 is 59 divided by summation P0 Q1 is 52 into 100. We get 59 divided by 52 into 100, which is 113.46. Right, now don't compare Laspeyre with Paasche. Of course these numbers will be different because the approaches are completely different. Right, that is why towards the end we'll be having tests for adequacy and we'll decide which is ideal, which we should be using in most of the cases. Okay, right now let us just use all the different approaches available. So next is Dorbish-Bowley. Right, Dorbish-Bowley. So one way of defining Dorbish-Bowley is Laspeyre's price index plus Paasche's price index divided by 2. Let's calculate this, and also in case where we don't have Laspeyre's and Paasche's, how to directly calculate Dorbish-Bowley, that also we'll see. Okay, so Laspeyre's is 121.15 plus Paasche's is 113.46 divided by 2 will be 121.15 plus 113.46 divided by 2. So 117.305 or 31. Now shall we calculate the same using the formula summation P1 Q0 divided by summation P0 Q0 plus summation P1 Q1 divided by summation P0 Q1. Just you need to remember Laspeyre's and Paasche's. If you know that, rest everything is just variations of that. So into 100 divided by 2. So this will be summation P1 Q0, which is 63 divided by 52 plus 59 divided by 52. Straight away I am referring to these and writing. Correct? Into 100 divided by 2 will be 63 divided by 52 is 63 divided by 52 1.2115 plus 59 divided by 52 is 1.1346 divided by 2 into 100. So 1.2115 plus 1.1346 divided by 2 into 100, I'll get 117.305, which is 315. You have to get the right answer. There is no rocket science in this, right? The Dorbish-Bowley is arithmetic mean of Laspeyre plus Paasche. That is how we get this formula also. Nothing is getting changed. So Dorbish-Bowley, under both the methods, I have given you the same answer. Clear? Next, Marshall Edgeworth, right? Marshall Edgeworth price index number. Correct? So now what is Marshall Edgeworth? Add the numerators divided by add the denominators of Laspeyre and Paasche into 100, which means summation P1 Q0 plus summation P1 Q1 divided by summation P0 Q0 plus summation P0 Q1 into 100. So this is how we do Marshall Edgeworth. So this will be 63 plus 59 divided by 52 plus 52 into 100. Correct? 63 plus 59. I am just writing this. No, you basically extend this divided by, right? You basically extend this, so make this plus plus into 100. So 63 plus 59 is 122 divided by 52 plus 52 is 104 into 100. So you get 122 divided by 104 into 100, which is 117.31. Huh? So does this mean Marshall Edgeworth and Dorbish-Bowley is same? No, we are getting same because our denominators are coinciding here. So which is what is making you feel so probably this is same, but not always the case. Okay, so that is about Marshall Edgeworth. So Dorbish-Bowley, Marshall Edgeworth. Now we come to the last one, which is Fisher's ideal index number. Fisher's ideal index number. What does Fisher say? Fisher says price index number is geometric mean of Laspeyre's and Paasche. Geometric mean of Laspeyre's and Paasche. So square root of Laspeyre. What is Laspeyre's number? 121.15. 121.15 into Paasche is 113.46, right? 113.46. What is the square root of this? Straight away calculator. 121.15 into 113.46. Whatever you get, square root of that, 117.241. So 117.24. Now what if you don't have Laspeyre and Paasche available? No problem. We'll just be multiplying them. So summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1. The entire thing into 100. Correct? So in the square root I'll have 63 divided by 52 into 59 divided by 52. I hope you are catching up with me about where I am getting the values from. All from the first table itself, and the same numbers we are using at various places, right? So I'm just referring this and writing it here. So 63 divided by 52 into 59 divided by 52 into 100. Okay, so you will have 63 divided by 52. I'll put this into m plus in the calculator because these are decimals, sometimes rounding off matters, so I'll put this into m plus. 59 into divided by 52, whatever I get, I'll multiply this with memory recall and I get 1.37. So let me do the square root of that into 100. I get 117.24. Okay, I hope you have followed with what I did in the calculator. If not, I'll tell you what I did once again, and I'll also tell you how to take up the rounding up and do it as well. Okay, so now come to your calculator. Take your calculator and make sure on your screen m is not there, the memory is not there. Now I'll do 63 divided by 52. I get 1.211538 blah blah blah, right? I want to preserve all of these decimal points. How will I do that? I'll click on M plus. Now what happens is this number is saved in the memory of your calculator. Now click on all clear AC. You will notice that M is still there. That means that number is still in the memory of the calculator. Now I'll do 59 divided by 52. Now I get one number 1.134615. Now what I'm supposed to do, this number multiplied by the earlier number, right? So this number into, so whatever is there on your screen, 1.1346. Now click on into and click on MRC. MRC stands for memory recall. So I want to recall the memory. I have clicked multiply. So 1.1346 multiplied by what is there in my memory. Okay, I'll click on is equal to, now I get 1.3746. 1.3746. Now this is the two products, whatever I got, no, like two numbers I got, no, it's product. So I have done the multiplication. Now what am I supposed to do? I need to get the square root of this. I get 1.1724 multiplied by 100. I get 117.24. 117.24. Did you understand how I did it directly in the calculator? Did you understand? If not, if this is too much for you to understand, first of all, you can pause it and replay and check. But if it is too much for you, let's make it simple. 63 divided by 52 is 1.2115 multiplied by 59 divided by 52 is 1.1346. So now 1.2115 into 1.1346, you get 1.3745. Now click on square root, you get 1.1724 multiplied by 100, you get 117.24. Is that clear? Is that clear? So what I have done is I have taken one single question and I have made you calculate all of this. But of course, in the exam, they'll ask what is the Laspeyre's price index number. So for Laspeyre's, whatever you need. For Laspeyre, you will need what? P1, Q0 and P0, Q0, right? Just calculate this much and you can go ahead with the answer. Okay, if Paasche is asked, you will only need P1, Q1 and P0, Q1, calculate that and proceed. If Dorbish, Bowley, Marshall, Edgeworth or Fishers is asked, we will need all of this. So first prepare the table with all these combinations and then use the formula of Dorbish, Bowley or use the formula of Marshall, Edgeworth or use the formula of Fishers. Is that clear? Is that clear? Wonderful, wonderful calculation there, right? Great. All of you did a great job there with calculating it with me. So with that, weighted aggregative index numbers are done. Weighted aggregative index numbers. Now, one thing to notice here is that, guys, we are taking all of this as price index number. Now, if quantity index number is there, it will all be the inverse. That means if quantity Laspeyre's is asked, if quantity Laspeyre's is asked, we are comparing quantities, correct? So it will be summation Q1 divided by summation Q0. Base year, current year, this logic remains the same. So we are starting with quantities. So summation Q1 divided by summation Q0. So if Laspeyre's quantity is asked, it will be price of base year, which will be the weights. Are you understanding? If we take the quantity Laspeyre's, then it will be quantity which comes first. Laspeyre told base year prices. Similarly, quantity Paasche's will be summation Q1 divided by summation Q0. So that will remain the same. Here, prices of current year. Are you getting the difference here? Are you getting the difference here? The focus is price. That's why we take price and then see what weights to take of quantities. Here the focus is quantity. Then we see what weights to take. Laspeyre, base year prices and Paasche's current year prices. Okay, is that clear? So I just want you guys to remember that this was for price. Similarly, you will have for quantities as well. Is that clear? Is that clear? Awesome. So that's about weighted aggregative index numbers or weighted aggregative index method. Is it clear? Superb. Let us now discuss about weighted average of relatives. Now in that, as we have seen earlier in simple average of relatives as well, we'll have two approaches, one using the arithmetic mean and the other one using the geometric mean. And as earlier discussed as well, we'll only be focusing on arithmetic mean method. So the price index number is equal to summation W into P divided by summation W, which stands for W is the weights. It can be whatever. If you want Q0, that is the weights. If you want Q1, that is the weights. Or if you want something else as the weight, that can be the weights. And P here stands for price relatives. Remember price relative in simple average of relatives, the same price relative. That means commodity wise we'll calculate the price relative and then multiply by the weights. Then we get summation WB divided by summation W. Okay, and the GM formula is like this: anti-log of summation W log P divided by summation W. But for this, we'll need log and anti-log. For that reason, it is not discussed here. Understood? Wonderful. So let's take a question on this to find out weighted average of relatives price index, summation WP divided by summation W. Okay, so we have a question here. Given below are the data of prices of some consumer goods and the weights attached to various items. Compute price index number for the year 1985, base year 1984 is equal to 100. So we have items, their units, and these are the prices, right? Prices of some consumer goods, and we have weight. Is this weight kg or what it is? Not given, doesn't matter. So I need P01, which is summation WP divided by summation W, right? So let me write down items P0, right? 1984 is P0, 1985 is P1. I need price relatives, then I'll multiply them with weights, I'll get WP. This is what I'll need, right? So the items are wheat, milk, egg, sugar, shoes. Huh? It's okay. They didn't say these are just eatables, right? So they just told consumer goods, so it's fine if we have shoes in the list. Okay, cool. So P0 is 0.5, 0.6, 2.00, 1.80 and 8.00. Where will you get shoe for 8 rupees? Guys, this is of 1984. We never know, we were not born, right? Let's not comment on that. So 0.75, 0.75, 2.4. Look at this, yeah. Eggs cost 2 rupees, it seems. Shoe only 8 rupees. What kind of values are this? But it's okay. This is just for the sake of example, right? Nothing to do with the reality, right? These are just questions for which we need some numbers. Okay, the price relative will be what? P1 divided by P0 into 100, correct? P1 divided by P0 into 100. P1 divided by P0 into 100 is what we'll need. So here P1 divided by P0, 0.75 divided by 0.5 into 100, you get 150. Next 0.75 divided by 0.6 into 100, you get 125. 2.4 divided by 2 into 100, you get 120. 2.1 divided by 1.8 into 100, you get 116.67. Correct? Let me check. 2.1 divided by 1.8. Correct. 116.67. Then we have 10 divided by 8, which is 1.25 into 100, which is 125. So we got all the relatives, right? We call this price relatives. Now multiply with the weights. 25481. 150 into 2 is 300. 125 into 5 is 625. 120 into 4 is 480. 116.67 into 8 is 933.36. 125 into 1 is 125. So I'll need summation W, I'll need summation WP. So summation W will be 2 plus 5 plus 4 plus 8 plus 1, which is 20. Summation WP is 300 plus 625 plus 480 plus 933.36 plus 125 is 2463.36. Correct? 2463.36. So we have summation WP and summation W. So P01 will be 2463.36 divided by 20, which will be 123.168 or 123.17. Understood? That simple it is to calculate weighted average of relatives price index. So weighted AM of price relatives P01 is equal to summation WP divided by summation W, which is what we have taken here for this question. Understood? Wonderful. So that is about all the different types of index numbers that we can calculate, right? If I take you back here, simple aggregative, simple average of relatives, weighted aggregative, weighted average of relatives. All of this we have discussed successfully, right? Awesome. So that is our one set of discussion. Now the next concept that we'll be discussing is called as the chain index numbers. The chain index numbers. So far we have concentrated on a fixed base, but it does not suit when conditions change quite fast. Correct? What we have been doing is we are taking 1 year as the base and we are calculating for all the different years. But reality wouldn't be like that. Fixing it on 1 year may not make sense. See 1984, 1985, if you take those figures and continue the index till 2000, 2010, 2020, 2025, 2026 that we are right now, doesn't make any sense, right? Correct? It doesn't make any sense. Isn't it? So that being the case, we might need something which is called as chain index number. That means it keeps on continuing, the base keeps on shifting. So in such a case, the changing base, for example 1998 for 1999 and 1999 for 2000. So for 2000 we are taking 1999 as the base, and so on, may be more suitable. If, however, it is desired to associate these relatives to a common base, the results may be changed. That means, let's say you want to change the bases, but also you want to have a chain. You want to know where did we start from. If you want to know both of this, we'll make use of chain index. Thus, under this method, the relative of each year are first related to the preceding year, called the link relatives, and then they are chained together by successive multiplication to form a chain index. So that means first previous year to next year relatives we are going to calculate, which we call as link relative. Then from there we'll calculate chain index using the formula link relative of current year into chain index of previous year divided by 100. Okay, let's see how to do this. So let's say we have data of multiple years like this, years 1991 to 2000, and price is given. So if we are to calculate chain index number, first we need to calculate link relative. Correct? First we need to calculate link relative. Link relative is basically price relative for every second year compared with the first year. So link relative, of course everything starts from 100. For the next year, link relative is 60 by 50 into 100, 120. Are you understanding? 60 by 50 into 100. Next, 62 by 60 into 100. Next is 62 by 60 into 100. So 62 by 60 into 100, you get 103.33. 62 by 60 into 100. Next, 65 by 62 into 100 is 104.84. Next, 70 by 65 into 100. 70 by 65 into 100 is 107.69. So for every year I am taking the previous year as the base. Are you observing that? 65 divided by 62 into 100, 62 divided by 60 into 100. So that is how we are getting these numbers. Next, 78 and 70. 78 divided by 70 into 100, we get 111.43. Next, 82 divided by 78 into 100, I get 105.13. Next, 84 divided by 82 into 100, I get 102.44, and next 88 divided by 84 into 100, I get 104.76, and last 90 divided by 88 into 100, I get 102.27. Understood? So like this we have calculated link relatives, right? So under this method, relatives of each year are first related to the preceding year, called the link relatives, and then they are chained. Now how do we chain it? Using the formula given here. Chain index is equal to link relative of current year into chain index of the previous year divided by 100. So here chain index, everything starts from 100. So now for the next one, link relative of the current year, 120 into 100 divided by 100. So 120 into 100 divided by 100, I get 120. Next, for the third year, chain index is link relative of the current year. So 103.33 into chain index of the previous year divided by 100. So 103.33 into 103.33 into 120 divided by 100. So you get 123.99 or 124. Correct? Next, just continue the trend. 104.84 into 124 divided by 100. So 104.84 into 124 divided by 100, you get 130. Next, 107.69 into 130 divided by 100. So you get 140. Next, 111.43 into 140 divided by 100, you get 156. Next, 105.13 into 156 divided by 100, you get 164. 102.44 into 164 divided by 100, you get 168. 104.76 into 168 divided by 100, you get 175.99, which is 176. 102.27 into 176 divided by 100, you get 179.99, which is 180. So did you observe what we did here? For every passing year, we took the base which were changing, correct? We took the bases as changing, and then we calculated link relative, and then we chained them up, correct? Then we chained them up. If you observe, this chain index are basically price index of 1992 compared to 1991, 1993 compared to 1991. Check this. 65 to 50, correct? 65 to 50, there was an increase of 15, correct? So 65 divided by 50 into 100 is 1.3 or 130. Correct? So these individual numbers are price index only. We use the link relatives and then we chained them up. So even if we don't chain, if you calculate price index for any of these numbers compared to the base year, you would still end up with this. Look at this, 70 current year divided by base year 50 into 100, you would get 140. Understood? So chain index number is again not a new concept. This is just chaining, where you get the link. You are comparing every passing year, then you get it back to the index numbers. That is what we call as chain index number. Is it clear? Did you understand? Basic, right? Not too complicated, just a little bit of steps involved, but ultimately what you get is same logic. If in 1991 it was 50, in 1994 it is 65, so what is the price index? Understood? So that is how we calculate chain index numbers. Is it clear? That is how we calculate chain index numbers. Awesome. So that is about chain index numbers. Now, this quantity index number, I have already explained you when we discussed price index number. I told you if you change your point of view from price to quantity, you will have this, right? So with that approach, I have included a question for you guys in quantity index number. So I'll just give you how to go about this. I want you to do the calculation. Okay, so now commodity is there, base year price, so P0 and Q0 is there, current year price and quantity is there, right? Now what we are supposed to calculate is quantity index number. That means I will be looking at Q1 P0, Q0 P0, Q1 P1, Q0 P1. Are you understanding? Nothing is changing. Mathematical calculation will remain the same, but the focus is on quantity. We are calculating quantity index number. So I'll need Q1, Q0, then again Q1, Q0. Understood? Is it clear? So every formula that we have discussed can be done with quantity index numbers also. That means Laspeyre's quantity index number will be summation Q1 P0 base year price, correct, divided by summation Q0 P0 into 100. Calculations, I want you to do it. I'll not be doing it. Paasche's quantity index number will be summation Q1 P1 because current year prices will be taken divided by summation Q0 P1 into 100. Understood? So Laspeyre, Paasche. Similarly, I want you to do all of them. I want you to do Dorbish-Bowley quantity index number. I want you to do Marshall-Edgeworth quantity index number. Marshall-Edgeworth. Okay, I hope you guys can do this. I trust that you guys know and have understood this. Next, also Fisher's, right, quantity index number of Fisher's. So I hope you'll be able to do all of this, isn't it? Right? Awesome. Okay, so I'll not be doing this sum. I just wanted to give you a little heads up about how a quantity index number can be calculated. With this much of basics, I believe you all will be capable to do this. Don't skip this. This is there in your material. Please take this question and solve this very carefully. Is that okay? Wonderful. So that is about quantity index number. And next we have something called as value indices, value index number. Okay, price index number, quantity index number, value index number. Now when it comes to value index number, we are looking at a combination of price and quantity. What is value? Price is not multiplied with quantity. Quantity is not multiplied with price. When you multiply price with quantity, you get value. So price anta ಹೇಳಿದ ಕೂಡಲೇ you just think of price per item, right? But quantity information is also very relevant to understand how much was the expenditure in the base year compared to how much was the expenditure in the current year, or how much is the sales compared to how much is the sales in the current year. For these kind of scenarios, you will need value indices, right? If your intention is just to compare the prices, price index, just to compare quantities, quantity index, but if you want to compare the sales in the base year compared to the current year, or expenditure in the base year compared to the current year, we'll use something called as value indices. So the value index number is calculated as summation V1 divided by summation V0 into 100, which is basically summation P1 Q1, present year price into quantity, current year price into quantity is current year's value, no? Simple. Divided by base year. What is base year value? Base year ka price into quantity. Understood? Base year ka price into quantity, current year ka price into quantity. So that is how we calculate value index number. Quickly, let us calculate this. So commodity A, B, C, D. P0 is 4572. Q0 is 3423. P1 is 6691. Q1 is 2425. So now I'll need P1 Q1 and P0 Q0. Just these two. Right? So P1 Q1 is 6 2s are 12, 6 4s are 24, 9 2s are 18, 1 5s are 5. P0 Q0 is 4 3s are 12, 5 4s are 20, 7 2s are 14, 2 3s are 6. So just I need these two totals. So 12 plus 24 plus 18 plus 5, which is 15, 9, and 12 plus 20 plus 14 plus 6, which is 52. So what is the value index number? Value index number V01 is summation P1Q1 divided by summation P0Q0 into 100, where you get 59 divided by 52 into 100. The answer is 59 divided by 52 into 100, 113.46. So this is the value index number for the question given here. Did you understand? Did you understand? So with that, we have discussed all varieties of price index number, quantity index number, value index number, and chain index number. Is that clear? Awesome. We'll have some more concepts coming up. Okay, great. Let us now discuss about usefulness of index numbers. The limitations is what we'll discuss first, and then we'll also discuss about where are those areas where it can be used. Okay, so as always, every concept will have its plus and minus. So let us see what are the limitations of index numbers. First one, as the indices are constructed mostly from deliberate samples, chances of errors creeping cannot be always avoided. That means we will take samples depending on our bias, right? That means now let's say we are calculating price index, we'll pick those items which we feel are most relevant. For example, let's say you are calculating price index for let's say the household items. Let's say you will take rice, you will take vegetables, you will take egg and some other item. Now here you are not representing the entire population, right? You are just making an assumption, probably these are the bare minimum anyone would consume, and you are calculating, which means that we are taking deliberate samples. So chances of errors creeping in will always be there, it cannot be avoided. Since index numbers are based on some selected items, they simply depict the broad trend and not the real picture, right? They just give you a broad trend, it is not the real picture. Since many methods are employed for constructing index numbers, the result gives different values, and this at times creates confusion. We have seen different ways of constructing an index number, right? We have simple index numbers, weighted index numbers. Again, in simple we have aggregative, average of relatives. In weighted we have Laspeyre, Paasche, Marshall Edgeworth, Darvish Bowley, Fishers. So there are so many methods in which you can calculate index number, which means that you choosing a particular formula will give you a completely different answer compared to some other person using a different formula. So there is no standardization in which we do the calculation, so that at times will create confusion. You will have to be very specific which formula was used, what was the assumption made, otherwise the judgment or the conclusion that you arrive would change. Understood? So these are some limitations of index numbers. In spite of its limitations, index numbers are useful in the following areas. What are those areas? Framing suitable policies in economics and business. See, in the beginning also I told you, index numbers is not something which is just like a time pass chapter. Even though the calculations look pretty easy, the impact is very huge. Now, let's say government, when they make policies, let's say about the rate of interest to be charged on the loans, or let's say they come up with the budget, government every year comes up with the budget, right? So when they come up with the budget, they'll announce tax cuts or price cuts, or they'll say inflation is this much, so we need to do this. So how do they do that? They compare what happened in the past. They'll see what is the increase in the price of a particular product, or how is the taxation impacting the people. Based on that, they'll observe the trend, they'll calculate an index depending on which they will announce further policies. So that is where this is very, very helpful, framing suitable policies in economics and business. Next, they reveal trends and tendencies in making important conclusions in cyclical forces, irregular forces, etc. So whenever there is an important trend that you're observing, reveals trends and tendencies in making important conclusions. So it helps you detect what is happening. If you see that the price is increasing exponentially, you get to know through an index number. Let's say the base year is 100, and for a particular year, let's say the price index comes to be 200. It means that it has doubled. right? So these kind of trends can be detected early with the help of index numbers. Third one, they are important in forecasting future economic activity. They are used in time series analysis to study long-term trend, seasonal variation and cyclical development. So if you have data for a considerably large period of time, what happens is you'll get to know, is there a cyclical movement, is there a seasonal movement, what kind of long-term trend are we looking at. So this is very helpful in forecasting what might happen in the future. Index numbers are very useful in deflating, that is, they are used to adjust the original data for price changes and thus transform nominal wages into real wages. We have a concept called as deflating time series using index numbers. Okay, we'll come to that just after this discussion, so please hold on till that. You'll understand what is deflating. Okay, deflating is a very important concept which helps you take the best out of index numbers. Okay, and the last one, cost of living index numbers measures changes in the cost of living over a given period. So there is an index which is called as cost of living index. That means cost of living, right? How do you live? How much cost is incurred in living? Basically, the day-to-day household expenditure. So that gives you a very clear picture about which city, how much are they consuming, how much are they spending, and stuff like that. So these are some advantages or uses of index number. So that was about the limitations and the usefulness. Okay, deflating time series using index numbers. Now what is this? Deflating is the technique used to make allowances for the effect of changing price values. It is used to measure for the purchasing power of money. So what is happening here? Let's take an example. I'll be able to explain it very easily for you. See, we have 4 years and their wholesale price index and corresponding GNPs at current price. Now, what is GNP? Gross National Product, something like GDP only, right? So there, now what happens is these numbers, whatever you have, right, these have inflation adjusted inside of them. Now, what do I mean by that? 7499 is with the corresponding price index of 113.1. That means there is 13.1 of inflation included in this. What do I mean by that? We are starting somewhere with 100, no, some base here 100. When I say wholesale price index is 113.1 compared to 100, it is 13.1% more. Correct? That means 7499 is considering 13.1% more. So what if we bring back 7499 to 100 price index level? Are you understanding? So that is what we are going to do for all the years. That means remove the inflation adjustment that is there in the values and bring it back to the same base year. First year 7499 with 113.1. So remove 13.1 from that. Next 7935 is when you have 116.3. Remove 16.3 from that. Next one 21.2. Next one 27.7. So that way we are going to remove the inflation. That's why the word deflation. We are removing the inflation that is there. The purpose is when we do that, we'll understand the real purchasing power of money. Is there anything apart from inflation which is affecting the numbers? So that is what we'll be able to do with the use of a concept called as deflation or deflating. Understood? There is a formula, current value divided by price index into 100, but let me tell you the easier way to do it, guys. 7499 is when it is 113.1. So what is it when it is 100? Common sense, I told you, right? Common sense in cross multiplication. Those two things are enough for index numbers. So if 113.1 gives you 7499, what is 100? That is what we'll get as the real GNP. So what we have here is called as nominal GNP. Okay, these are economics terms. So nominal GNP, we are converting them into real GNP. How do you do that? If 7499 is 113.1, what is it for 100? So this is exactly what is given in the formula. 7499 divided by 113.1 into 100, which is 7499 into 100 divided by 113.1. Are you understanding? So you simply have to take the GNPs divided by wholesale price index into 100. Okay, shall we do that? Great. So 7499, so let me put the heading here as real GNP, will be 7499. Real GNP will be 7499 divided by 113.1 into 100. 7499 divided by 113.1 into 100. So what is it? 7499 divided by 113.1 into 100, you get 6630, right? You get 6630. For the second year, we have 7935 divided by 116.3 into 100. So 7935 divided by 116.3 into 100, we get 6823. Right, 6822.87, which is 6823. The next two I'll directly do in the calculator. 8657 divided by 121.2 into 100, you get 7142.73, which is 7143. Next, 9323 divided by 127.7 into 100, you get 7300.7, which is 7301. So these are the real GNP numbers. Now this is how the price has moved if you keep out the inflation. So that means even if there was no inflation, the prices would have gone up, probably due to reduction in the supply. Maybe the production was less, so because of that the prices went up, right? So there are other factors also which influence the price change, right? So probably that is why the numbers have changed. Here these numbers had a bit of inflation adjustment. These numbers don't have those inflations. Is it clear? Wonderful. So that is this concept of deflation or deflating time series using index numbers. Okay, next we have another interesting concept, that is shifting and splicing of index numbers. Shifting and splicing of index numbers. These refer to two technical points: how the base period of index may be shifted. So when I say shifting, we shift the base period. That means let's say you have data from 2000 to 2020, and let's say 2000 was 100, then you have the index numbers. But 2000 to 2020 is 20 years, too many things would have changed, right? So it doesn't make sense to keep the index number as 2000 as 100. So you would want to move it from 2000 to let's say 2010. So when you bring it to 2010, now 2010 is 100, so you will calculate the remaining and you will also adjust the previous values. Are you understanding? So shifting of base makes your data or makes your index number become even more relevant, because the base year is never relevant year. Are you understanding? Wonderful. And the second one, splicing, how two index covering different bases may be combined into single series by splicing. Now what is happening here? Let's say you have one set of data from 2010 to 2020 and someone else started another set of series from 2020 being 100. Now what happens here? You have data from 2000 to 2020 or 2010 to 2020, whatever, right? So you have one series and the second series is starting again, right? So for the same data, just because you started somewhere else, you're having two series, better to merge these, right? So that merging of series is what we call as splicing. So we are splicing and bring it to one series. That is what we are going to do when splicing of index numbers. Is that clear? Awesome. So base shifting, how do you shift the base? The formula is original price index divided by price index for new base year into 100. And when it comes to splicing, we'll come to that a little later. We'll straight away take a question on shifting. Is that okay? We'll take one thing at a time. So we'll do shifting first and then we'll discuss about splicing. Okay, so shifting. Find the index number by changing the base to 1990. Okay, so what is happening? We have the original price index which is starting at 1980 being the original price index 100. Then for every year we are calculating with 1980 as the base year. Right, now the requirement is to change the base to 1990. So we are going to change the base to 1990, which is what we call as shifting the base, shifting of index numbers. Now how will you do that? Right now this is 100 and this is how the values are, but we would want to make this as the new 100, right? So that means common sense, I'll tell you first, then we'll go to the formula. Okay, so if 140 becomes 100, what happens to 131? If 140 becomes 100, what happens to 125? Isn't this how we do it? That means how are you going to calculate? If 140 is 100, 131 is what? So 131 into 100 divided by 140. Correct. If 140 is 100, 125 is what? That means 125 into 100 divided by 140. So 125 into 100 divided by 140. So now if I want to make this into a formula, what is the formula? The original price index divided by price index of the new base year into 100. Understood? That is how we come to the formula of shifting, which is original price index divided by price index for new base year into 100. Is that the formula? Yes. Original price index divided by price index for the new base year into 100. Very simple, very straightforward. So what are you supposed to do? Original price index divided by price index for the new base year into 100. So 100 divided by 140 into 100. So this will be 71.43. Next is 104 divided by 140 into 100. So I get 104 divided by 140 into 100, which is 74.29. Next, shall I directly do it in the calculator? 106 divided by 140 into 100, you get 75.71. 107 divided by 140 into 100, 76.43. 110 divided by 140 into 100, you get 78.57. Correct? 110. Next, 112 divided by 140 into 100, you get 80. Next, 115 divided by 140 into 100, you get 82.14. Pretty straightforward, right? Now, nothing complicated here. Next, 117 will be 117 divided by 140 into 100, you get 83.57. Likewise, you will continue this, right? So 125 divided by 140 into 100, 89.29. 131 divided by 140 into 100, 93.57. 140, should I calculate? 140 is the new 100. No, that is the whole point, right? So 140 divided by 140 into 100 has to be 100, guys. That is the whole point. I want to make 1990 as the new base year. So 140 I am equating as 100. So all the numbers will now recalculate and sit as a number equivalent to 140 being 100. Right? Next, 147 divided by 140 into 100 will be 105. Are you getting the logic? Here we started from 100 and we went on increasing based on the years, right? Here what is happening? 140 will be the 100. So from here the index numbers will go from 100 and onwards. Accordingly, these will adjust to a value less than 100, no? Because now this becomes 100, 140 becomes the new 100. So that means all the values will go adjusted and sit starting from 71, 74, 75, 76, 80, 83, 89, 93, 100, 105. Are you understanding? Wonderful. So that is the concept of shifting of index numbers. Let us now discuss about splicing of index number. Okay, splicing of index numbers. What is splicing? The process of combining two or more index numbers covering different bases into a single series is called as splicing. So here we are combining two or more index numbers covering different bases. There are two sets of data with different bases, so we are going to combine them. Okay, now when you combine, you can have two ways of combining. There is a series A, series B. You combine, A is spliced with B. That means you are merging, like I'll show you an example. You will have B datas and A datas here. A is spliced with B means A is merging with B. B is spliced with A means B is merging with A. Okay, let me not make it too complicated. Let me directly take you to an example. Following are the two series A and B of the index numbers of a commodity taking 1991 and 1994 as the base years. Splice the index series of A to B, splice the index series of B to A. That means, look at the example. What has happened? There is one set of series which is started with 1991 as the base year and you have 4 values. There is another set of series where 1994 is taken as the base year and you have another series. Now we want to merge this. One way of merging is A, you bring it to B. So you will have one series here. Or you take B to A. Correct? Now when you do that, observe what you need to do. Common sense. A will now merge with B, right? First is splice index series of A to B. So A will merge with B means what? There is one common here, right? That is necessary. There is one common here, and this will give you the clue. If 150 was 100, if 150 was 100, what will be 125? If 150 is 100, what will be 125? So 125 into 100 divided by 150. Correct? 125 into 100 divided by 150 will be the answer here. So what is happening? Index series of A, correct, divided by the next one or the common one into 100. Correct? 120 into 100 divided by 150. Shall we check the formula? Index series of current year, index A of current year divided by index A of common year into 100. That is exactly what I am doing here, right? 125 divided by 150 into 100. Correct? See, this is why I tell guys, common sense is very important. Otherwise, you would have learned this as a new formula altogether, right? Now I just showed you. If you look at the example, you'll get to know what needs to be done. 150 is equated to be 100. What will be 125? Shall we do that? So 125 into 100 divided by 150, correct? So this will be 125 divided by 150 into 100. So it will be 125 divided by 150 into 100 is 83.33. What about 90? If 150 is 100, 90 is what? So 90 into 100 divided by 150. So 90 by 150 into 100, you will get 90 by 150 into 100 is 60. 100 is 100 divided by 150 into 100, 66.66 or 67. Now you tell me what will happen to the remaining values. It will continue to be 100, 120, 150, 200 and 225. Why? What are we doing? Merging A with B, no? Splicing A to B. So remaining values will be of B. These three values will be adjusted back. Understood? So we have one series with 1994 as 100 and forward and earlier values spliced. Correct? These are getting spliced, these are getting merged and brought back. So that is splicing. What if we want to splice B with A? Matlab, what are we doing? B is now going to merge with A. That means we have a common here with 100 now being equated to 150, right? If 100 is 150, what will happen to 120? Correct? If 100 is 150, what will happen to 120? So how will the calculation go? 120 into 150 divided by 100, correct? 120 into 150 divided by 100. So 120 into 150 divided by 100. What happens to the next year? 150 into 150 divided by 100, correct? So 150 into 150 divided by 100, right? So that is how the values will continue. So let me write it right in front of that. So 120 into 150 divided by 100. Correct? So this is how it will continue. Exactly the same thing has been put as a formula here. Index B of the current year into index A of common year divided by 100. Index B of current year into index A of common year divided by 100. Index B of current year into index A of common year divided by 100. Right? So that's how the calculations will continue. So 120 into 150 divided by 100 is 180. Next is 150 into 150 divided by 100 is 225. Next is 200 into 150 divided by 100. 200 into 150 divided by 100, you get 300. Next is 225 into 150 divided by 100, you get 225 into 150 divided by 100 as 337.5. Now you tell me what happens to the remaining values. It will be the continuation of A, that is values of A. Why? B is now getting merged with A. So this will remain to be 100, 90, 125, 150. From there you are continuing, right? Till here these values, from there you are continuing. When you are continuing, you are bringing it back and equating it here, correct? So B is getting merged with A. Did you understand? So these are the values: 66.7, 60, 83.33, 100, 120, 150, 200, 225. B to A is 100, 90, 125, 150, 180, 225, 300 and 337.5. Is that clear? So these are the two concepts called as base shifting or shifting and splicing. Is that clear? Awesome. Now next we are moving into one important concept which will ultimately reveal us which is the ideal index number. Revealing is such just me hyping it. We already know which is the ideal index number, which is that Fisher's, right? We'll see why Fisher's is called as ideal index number. Now every index number is to be checked for certain tests of adequacy. Is this index number adequate? So there are four different tests. The first one is unit test. That means this test requires that the formula should be independent of the unit in which or for which prices and quantities are quoted. Except for the simple aggregative index, all other formulas satisfy this test. Wonderful, right? Except this one, every other formula satisfies. Let me give you an example and explain. What happens in simple aggregative index? We have, let's say, Maggie and chocolate, for example. We'll have 2025 2026 prices. How do we calculate simple aggregative? We total this up and then we compare, right? So this divided by this into 100 will do, correct? That is how we compare these two. So what is happening when I do the total? Here also I will total up and the answer is rupees, correct? Let's say Maggie is 20 and chocolate is 10. This will be rupees 30. Here also it will be, for example, 10 and 5 rupees 15. So my index number or the calculations that I'm going to take will remain to be rupees only, right? That means it is not independent of unit. Unit is going to stay back in the formula. But in rest all the formulas, for example, last year's, let's say, even though we start with summation P1, summation P0, we are bringing in a quantity, right? So when we bring a quantity, these are treated as weights here, correct? So the answer I am getting is independent of the unit. So answer is now not rupees. Summation P1 Q0 is not rupees. Why? Price is being multiplied by a weight, correct? So that is why all other formulas fulfill unit test. Wonderful. Second one, time reversal test. Directly I'll show you the formula, you'll be able to understand. Price index of 0, 1 into P10 should be 1. That means if I am calculating index number for the current year based on the base year, let's say base year is 2020, we call this P0, we call this P1, right? So P01 means base being 0, what is the price index for P1, that is 2025. So P01 is that. Now let's say you reverse this, time reversal. That means what if you now back calculate the price index for 0 knowing the price index for 1 year. That means if you know 2025 is something and you back calculate for 2020, we call it P10. If multiplication of this is 1, then we call that such a index number fulfills the time reversal test. Understood? So P01 into P10 should be equal to 1. And you know what? Laspeyre's method and Paasche's method do not satisfy this test, but Fisher's ideal formula does. Laspeyre's and Paasche's do not satisfy this test, but Fisher's ideal formula does. Okay? That means Laspeyre's we have P summation P1 Q0 summation P0 Q0, right? If we inverse that as P10, what happens? We'll have summation P0 Q1 divided by summation P1 Q1. When you cross multiply that, you don't end up with 1. To end up with 1, what should have happened? You should be able to cut it like this, right? That's not possible. All these are different for ones. P1 Q0, P1 Q1. Here it is P0 Q0, P0 Q1. So there is nothing in common, right? So with that, Laspeyre fails the time reversal test. Same is the case with Paasche's, it also fails. But interesting is Fisher's. Observe Fisher's, what happens? P01 is summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1 under the square root. And what about P10? Inversing everything, correct? So summation P0 Q1 divided by summation P1 Q1 into summation P0 Q0 divided by summation P1 Q0. Nothing to worry, guys. Like P10 was there, no? Here it becomes 01. That is how you reverse the time. That's all, right? So that being the case, when you simplify, what happens? This is square root and into this, so single square root, correct? And everything gets multiplied. If you observe, P1Q0 gets cancelled, P0Q0 gets cancelled, P1Q1, P0Q1, so everything gets cancelled, which means that we are left with is equal to 1. So that is how time reversal test proves that it is going to fulfill the time reversal test. Fisher's fulfills the time reversal test. Is that clear? Wonderful. So the unit test is clear, time reversal test is clear. Now the next is factor reversal test. Now what is this factor reversal? This holds when the product of price index and quantity index should be equal to the corresponding value index. So in this test, what we are going to check is P0 into Q0 V01. P01 into Q01 is V01. So we are going to check that in factor reversal test. And you know what happens here? Only Fisher satisfies the factor reversal test. So just like the time reversal test, even when it comes to factor reversal, Fisher satisfies it. Because Fisher satisfies both the test, that is time reversal and factor reversal, we call it an ideal index number. Now did you understand why we call Fisher's as the ideal index number? It fulfills both time reversal and factor reversal. How factor reversal is being fulfilled is given here. I leave it to you guys to check and confirm. Okay, just so that you get some heads up, I'll tell you what will end up happening. P1 Q0 is Q0 P1, Q1 P0 is P0 Q1. So you'll be left with P1 Q1 into P1 Q1, P0 Q0 into P0 Q0. Since it is under the square root, you will be left with summation P1 Q1 divided by summation P0 Q0, which is basically the value index number. Understood? So factor reversal test is P01 into Q01 should be V01. That has been confirmed in the factor reversal test. Right? So that is about the unit test, time reversal test and factor reversal test. Okay, then there is the fourth test called as circular test. It is concerned with the measurement of price changes over a period of time when it is desirable to shift the base. This property therefore enables us to adjust the index values from period to period without referring each time to the original base. Okay, this in simple is P01 into P12 into P20 should be equal to 1. So this is actually the circular test. We are not going to check this because this test is not met by Laspeyre's or Paasche's or Fisher's index number. So even Fisher fails when it comes to circular test, but this is one of the tests which is checked just to make sure, can I simply go on shifting the index numbers from one year to other and end up with the right answer always. So only simple geometric mean of price relatives and weighted aggregative with fixed weights meet this test. So both of this are not a contender for an ideal index number because Fisher's fulfills 2 of the 4 tests, that is time reversal and factor reversal. Just because simple geometric mean of price relative and weight aggregative fulfills circular, we don't call it ideal. Understood? So there is unit test which every formula fulfills except simple aggregative index. We have time reversal where Fisher's fulfills that. We have factor reversal where Fisher fulfills that. When it comes to circular, Fisher does not fulfill that, but there are 2 other formulas. Now from the exam point of view, what questions can come is, they will give you a question, which of the following does not fulfill this test or which of the following fulfills this test. You should be able to identify Fisher's, Laspeyre, Paasche's. That's all. Understood? Wonderful. So those are some tests for adequacy when it comes to index numbers. Now there are 2 time pass concepts, guys. Let's quickly discuss this. The issues involved. Now index numbers, the limitations, useful as everything we have studied, right? But there are certain things we need to be careful about when we are constructing an index number. Those are called as issues involved in index number. First one, selection of data. See, we have discussed, depending on our sample, our index numbers change, right? So we need to be very careful when we select the data. What kind of data are we going to select? Second one, base period. This is another crucial factor, right? What is your base year? Now mainly the base year should be a neutral year. Let me explain what I mean by neutral year. Now let's say you are comparing the data of price of a particular item, or let's say you are comparing the performance of the stock market for the last 10 years. In the last 10 years, we know that two things have happened. One is 2016 demonetization, the other one 2020 COVID, right? Now, both of this affects the performance of the market, right? Because in both of these years, the market had crashed. So when you calculate your index numbers, if you take any one of these years as the base, don't you think we'll be getting misled? Because if we compare everything with 2020, which was a bad year for the stock market, all other figures will look great. Correct? If 2020 is taken to be the base, every year will look to be awesome, because from there every year there was increase only, right? But that's not the case. If we take something, let's say from 2018 or something, that is when we'll get the real picture about how the market is performing, right? So selecting the base year becomes very, very crucial. Next, selection of weights. See, we have seen so many varieties. Laspeyre says current base year, Paasche says current years. We can also take any other weights, right? So what kind of weights are we selecting becomes very, very important. Use of average. Are we going with EM, GM? Right? Then choice of variables. When I say price index, am I referring to retail price? Am I referring to wholesale price? So that decision based on what is our end goal needs to be made. And selection of formula. Again, Laspeyre, Paasche, Marshall, Darvish, Bolly. Which formula will you select? Okay, so these are some things which we need to be very careful about. These are not the limitations, these are the choices available in front of you. So when you are making the choice, make sure you know what you are looking for, and based on that you choose what you want. Okay, so that is what we discussed under issues involved. Is it clear? Wonderful. Now probably we come to the last concept, then we'll have some MCQs. The last concept is consumer price index number or cost of living index number. Okay, how do we calculate this? I'll not give you an example where this is calculated, because this exactly borrowed from two formulas which you have already discussed. So consumer price index number under aggregative expenditure method, the formula is ditto Laspeyre's. Okay, so how do you calculate consumer price index number under aggregative expenditure? Take the formula of Laspeyre. So basically, I'll give you the concept. Cost of living index means an average household, an Indian household for example, how much does it spend on what? So there you are taking, this is the price of the product, these many kgs. For example, if I ask you cost of living index for a family of 4, you will give me rice is this much rupees per kg. This family consumes these many kgs per month. So this is their expenditure. This is their expenditure on rice. Then vegetable, price of vegetable is this much, these many kgs per month. So this is the expenditure. That's why we call aggregative expenditure. So there what we are doing is we are taking current year price with earlier year's quantity, base year's quantity, divide by base year price into base year quantity. Understood? So that is the logic of aggregative expenditure method. Then we also have a family budget method, which is exactly weighted average of relatives. So we take the price relatives for every item, that is rice this year, earlier year, price relative. Like that we'll take. Then we'll see how much weightage rice carries, how much weightage milk carries, how much weightage vegetables carry. Understood? So that is how we calculate family budget method, where the formula is summation WP divided by summation W. Is it clear? So that is about consumer price index numbers, guys. So with that, all the concepts of index numbers chapters are done. We'll next be moving towards some MCQs. Okay, awesome. Great. Let us now take some MCQs and we'll see what kind of questions we can expect for exams. First question, if the ratio between Laspeyre's index number and Paasche's index number is 28:27, then the missing figure in the following table P is, what is the table given? Commodity XY, base year price, we only have L, so we don't have the numbers here, quantity 10 and 5, current year price is 2P, quantity is 5, 2. Okay, what are we supposed to find? Missing figure in the following table P. So we are supposed to find out P. MCQs. But what to do, guys? If these values were given, I could have told we'll try trial and error. Of course, trial and error in statistics generally doesn't work because we'll have to see summation P1 Q0 divided by summation P0 Q0, all those calculations, right? But at least if this was there, somehow we could have tried something just using our calculator. But here, even price of X and Y for base year we don't have, right? So we'll have to see what is available, and with that we'll have to try calculating something. Laspeyre is summation P1 Q0 divided by summation P0 Q0 into 100, correct? And what about Paasche is summation P1 Q1 divided by summation P0 Q1 into 100. And we know the ratio is 28 is to 27. Now what do we do with that information? Can I say this divided by this is equal to 28 divided by 27? Correct, 28 divided by 27. Now this is the only information we have. We need to take it forward, so we can't cut this also. Correct, there is nothing in common which gets cancelled, so there is no way out with this, right? This is the approach. Then we'll have to see what can be done, but wherever possible we'll try to get the multiplications. No, for example, 2 into 10 will get 20. Those will be real numbers, right? So let's keep this aside for a minute and we'll see what else can we do about the whatever is given in the question, right? So let's keep this in one corner. We'll see how this will come to our help in a little later. So once that is there, so we'll go back to the basics. So we'll write x, y, base here is basically P0 Q0. We have P1 Q1. So Laspeyre Paasche. So I'll need all four varieties. So I'll write P0 Q0, or I'll start with P1 Q0, next one P0 Q0, next is P1 Q1, and give me a minute, let me push this downwards. Okay, I'll keep it here, P1 Q1 and then P0 Q1. So I'll need all these four varieties, right? So let's come up with that. So L, 10, 5, 2, P, 5, 2. P1 Q0. P1 Q0 is this one, right? P1 Q0 is 25P. P0 Q0 is 10L, 5L. P1 Q1 is 10 and 2P. P0 Q1 is 5L and 2L, correct? So this will be 20 plus 5P. This is 15L. This is 10 plus 2P. This is 7L, right? Cool. See, now the idea is we should somehow try to eliminate L so that we are only left with P, correct? Now if we use this ratio equation, there is a chance that we might be able to cancel off L. Now how is that? I'll show you. So summation P1 Q0 is 20 plus 5P, 20 plus 5P divided by summation P0 Q0 is 15L into 100 divided by summation P1 Q1 is 10 plus 2P divided by 7L into 100 is equal to 28 by 27. Correct? This is how we have it. Can I say 100 gets cancelled, numerator, denominator? Can I say L gets cancelled, numerator, denominator? Right? This is the trick. Now with this done, you tell me, isn't it so simple now? 20 plus 5P divided by 15 divided by 10 plus 2P divided by 7 is equal to 28 by 27. That means 20 plus 5P divided by 15 into 7 divided by 10 plus 2P is equal to 28 by 27. Correct? Correct? Now what? Or we can do one thing. Now what I'll do is I'll get 27 to the numerator here and this entire thing this side. Can I do that? Yes. So that means I'll have 27 into 20 plus 5P divided by 15 is equal to 28. I need to be a little bit careful here, right? So just give me a minute. We'll do one thing. 20 plus 5P divided by 15 into 7 divided by 10 plus 2p is equal to 28 by 27. So let's add up the numerator. So what I'll do is 7 into 20 plus 5p divided by 15 into 10 plus 2p is equal to 28 by 27. Correct? Are you understanding? Are you understanding this much? Now what? Now take this side and this side, right? Like just give me a minute. I'll show you what I mean by this that. Okay, yeah. So now 7 into 20 is what? 140 plus 35p into 27 is equal to 28 into 150 plus 30p. Are you understanding what I did there? I simplified this and took 27 this side. I simplified this and took it here. Right? So now I have 140 into 27, which is 3780, plus 35 into 27 is 945p, is equal to 28 into 150, 4200, plus 28 into 30p, which is 840p. Right? So now I'll do 945p minus 840p is equal to 4200 minus 3780. So 945 minus 840 is 105p is equal to 4200 minus 3780, which is 420. So p is equal to 420 divided by 105. So divided by 105 you get p as 4. I know the calculations are a lot here. Welcome to CA exams, right? So nothing comes easy here. So yeah, so it's about the time management. I have been stressing on time management a lot, right? These questions do take time where you're allowed to think what is the approach and do it. But the best part is when you solve a lot of questions, you will now know that okay, this question is like this. I have already solved this, so I need this step, right? That is the advantage of having solved lots of questions, and you should solve so many questions that all types of possibilities of questions you have already touched upon, right? When that is the case, you will know exactly what will be the steps. Now it is just about doing the steps. Here we had to think and then come with an idea, come with the strategy and then calculate, right? So the answer is 4. Do we have 4 as an option? Definitely yes, option B, 4. Did you understand? A crazy question. First MCQ itself is a bouncer, right? Okay, the next one. If the prices of all commodities in a place have increased by 1.25 times in comparison to the base period, the index number of prices of that place is now 125, 150, 225, none. 125? If you tell 125, I'll probably call you a dumbo, right? Come on guys, 1.25 times in comparison to the base price means 1.25 times increase. So if my current value is 100, it has increased by 125, correct? If my current value is 100, it has increased by 125, which means if my earlier price index was 100 or the earlier value was 100, 1.25 increase means it is 225. Correct? 125 means you are telling 0.25 times increase, 25% increase. 1.25 times increase means 125% increase. So 125 gets added to 100. So the option is 225. Is it clear? Don't get confused. If the index number of prices at a place in 1994 is 250 with 1984 as the base, then the prices have increased on an average by, relax, prices have increased by how much? Right? 250 is the index for this year with 1984 as the base. So prices have increased by how much percentage? 150 percentage. That is why your value is right now at 250. You started from 100, 150 percentage increase means 150 increase. So 250, that is how you look at it. So it's option B, 150%. Okay. Next question, if summation P and Qn means P1 Q1 is equal to 249 and summation P0 Q0 is 150, Paasche's index is given 150, Dorbish-Bowley's index number is 145, Fisher's index is supposed to be calculated. Wonderful question. So summation P1 Q1 is given to be 249, summation P0 Q0 is 150, Paasche's, right? Paasche's is given 150, Dorbish-Bowley is given 145, Fishers is what? Now, the minute you have Paasche and Dorbish-Bowley, definitely you should get an indication they are trying to tell you to solve using this one, right? Laspeyre and Paasche, because Paasche is already there. Now there comes the question, how will you get Laspeyre? Dorbish-Bowley is there. Now, what is Dorbish-Bowley? Laspeyre plus Paasche is divided by 2, right? I know Dorbish-Bowley is 145. Correct. I know Dorbish-Bowley is 145. Laspeyre I don't know. But Paasche I know, right? Paasche is 150 divided by 2. Correct. So what will be Laspeyre? 145 into 2, 290 minus 150 is equal to Laspeyre. 290 minus 150. So Laspeyre is 140. Correct. So we now have Laspeyre. Paasche is already given. So Fisher's price index, or whichever is the index, will be Laspeyre's into Paasche. So Laspeyre's is 140, Paasche is 150, square root of multiplication of that. So 140 into 150 is 21,000, square root is 144.91. 144.91. 75, 60, 145.97, none of this. So what do we do? 144.91 is not given in the option. Did we make a mistake anywhere? I don't think so. 145 into 2 is 290 minus 150 is 140. ICA does this, guys. You know what is the right answer for this one? It is none of this. Don't get confused thinking 144.91, so probably I went wrong somewhere. See, double checking your answer is fine, but don't feel like none of these is probably not the right answer. Don't come to that conclusion. Don't simply waste time thinking, was it 145.97? If you are sure what you've done is right, then tick none of this. Remember this, okay? I say does this very frequently to make you waste time and recalculating and check, why am I not getting 145.97? Why am I not getting any other number, right? Don't do that. If you're pretty sure about what you have done, you can confidently go with none of this. Is that okay? Wonderful. Superb question to trick us, right? From the following data for the 5 groups combined, food, cloth, power and fuel, rent and rates, miscellaneous, weights and index numbers are given. The general index number is to be calculated. Now, what is general index number? Never studied. Chill, no problem. What is given? Weights and index number. So they want general means basically grouped one, right? So how will you do it? This is weights. This is weights and these are price relatives or index number, doesn't matter, right? So we are going to use summation WP divided by summation W logic. Prices are given, that is index numbers are given, weights are given, right? We ultimately want an average, correct? So summation WP divided by summation W. So summation WP. So 35 into 425, 15 into 235, 20 into 215, 8 into 115, 22 into 150. So how are we going to do this? Directly with the calculator. No calculations, nothing, directly using the calculator. Shall we try this? Wonderful. So 35 into 425, 14,875. You get this in your calculator. Now plus M plus. Now press M plus. That means add this number to the memory. Next 15 into 235 is equal to 3525 M plus. Next 20 into 215 is equal to M plus. 8 into 115 is equal to M plus. 22 into 150 is equal to M plus. Now recall everything that is in the memory. We have added everything to the memory, right? Recall the memory, you get 26920. I hope you have caught this. I hope you did this in the calculator only. Wonderful. If you have done that, great. Now clear off the memory. Clear off the memory. Now weights ka total I need. How much is that? 35 plus 15 plus 20 plus 8 plus 22, which is 100. So 26920 divided by 100, 269.2. Option B. Did you understand? Did you understand? Pretty straightforward question. Don't get carried away with the usage of the word general index. They are not specifying which index to use. They are just expecting you to calculate. Now, there can be another question which comes like this. Look at this. Commodity ABC, price relative 125, 67 and 250. Weights are given. The suitable index number. They are not naming which is the index number, but look at the values given, guys. Price relative and weight. Isn't this summation WP by summation W again? Correct? So I'll not be helping you out with this. I want you to calculate. Options are available. You decide what is the right answer. Okay? Superb. Now, when the cost of tobacco was increased by 50%, a certain hardened smoker, what is hardened smoker? Who always smokes, who maintained his formal scale of consumption, said that the raise has increased his cost of living by 5%. Before the change in price, the percentage of his cost of living was due to buying tobacco is how much? Now, what they're asking is when tobacco's price went up by 50%, his cost of living went up by 5%. So, what was the percentage of his cost of living to his buying tobacco? So, how much percentage of his cost of living is related to tobacco? No formula here. See, guys, if value of tobacco went up by 50% and his cost of living only went up by 10%, that means out of his cost of living, 10% is going towards consumption of tobacco, right? Tobacco price went up by 50%. But his cost of living is not going up by 50%. No, that means there are other items he's consuming. He's not just smoking, he's doing other things also. Which means that in his total cost of living, 10% is coming from tobacco. So when prices of tobacco went up by 50%, his cost of living went up by 5%. Did you understand? So just a common sense question there. So the answer is 10% of his cost of living is tobacco. Understood? Wonderful. So with that, we come to the last question of index numbers. And index numbers is also the last chapter of statistics. Great job, guys. We have come a long way, right? We have come a long way to understand all of this. Amazing. I believe right now you have the confidence that you will score out in statistics. I hope that is the optimism with which you guys are listening to the class. Great, guys. Great. It has been wonderful teaching you all these concepts. Thank you for the opportunity. Okay, the last question. During the certain period of CLI, the CLI goes up from 110 to 200 and the salary of a worker is also raised from 330 to 500. Then the real terms is, remember we had solved a question on GNP, real GNP was asked. This is something like that. See what has happened, cost of living goes up from 110 to 200. Correct? From 110 it goes up to 200. At the same time his wages went up from 330 to 500. Then the real terms is loss by rupees 50, loss by rupees 75, loss by 90, none of this. Okay, so basically what we need to do is we need to deflate this and then compare what happened to the wages. Okay, so in year one, this is year 2, let's say, your CLI was this much, your wages was this term. So now can we get our wages to real wages number? Real wages number, how do you do that? 330 divided by 110 into 100. Correct? It comes to 300. Actual wage, that is 330 divided by CLI, which is 110 into 100, 300. Similarly, 500 divided by 200 into 100, you get 250. That means when CLI was 110, if you were getting a wages of 330, removing the inflation effect, your actual wage was 300. Correct? When your CLI is 200, if you are getting 500, that means real terms you're only getting 250. Are you getting the comparison? Right? That means ideally when 110 was 330, that means into 3, 200 into 3, you should have got 600, correct? But you're not getting 600. That in real terms can be defined as if 330 was brought back to 100, it would be 300. If 500 is brought back to 100, it is 250. That means when the CLI increased, even though the wage increased, you ended up losing 50 rupees. Only if you had made 300 rupees, you would have sustained the inflation. Here you are not beating the inflation. Even though inflation was moving from 110 to 200, your salary should have moved to 600. It didn't. So in real terms, right now you are at a loss of 50 in real. 300 was supposed to remain at 300. Yours is not remaining at 300. It is down to 250. So you have made a loss by 50 rupees. Is that clear? Awesome, guys. It was amazing teaching you all these concepts. I hope you have been able to understand all of this. If there is any doubts, please don't hesitate to reach out to me. With that, all the best, guys. Do well in exams. Do well in your life, and let's probably meet somewhere in the real life. And please come to me and introduce yourselves and let me know that you were one of my online students. That will really make me feel really good about you guys. So I hope the best for all of you. Pray to God or Almighty or whatever the bigger force that you believe in. Always be positive, stay positive, no matter what happens in life. Remember that it is just a part of life. CA is not your entire life, it's just a part of your life. Right now, make it your entire life and crack these exams and come out with flying colors. With that, it's me, CA Nandan, signing off. Thank you.